Lesson: Word problems and rational equations. Solve the problem or leave the problem. Do not live with the problem. Understanding work problems. If a person finishes a job in 10 hours, then in 1 hour, the person does 1/10 of the job. The person's rate is 1/10 of the job per hour. In 3 hours, the person does 3/10 of the job. If a pipe fills a tank in 4 hours, then in 1 hour, the pipe fills 1/4 of the tank. The pipe's rate is 1/4 of the tank per hour. In 3 hours, the pipe fills 3/4 of the tank. If a sink can be drained in 7 minutes, then in 1 minute, 1/7 of the sink can be drained. The sink's drain's rate is 1/7 of the sink per minute. In 3 minutes, 3/7 of the sink can be drained. If a person finishes a job in X hours, then in 1 hour, the person does 1/x of the job. The person's rate is 1/x of the job per hour. In 3 hours, the person does 3/x of the job. Work equals rate times time. If a person does 0.25 copies per second, then in 4 seconds the person does 1 copy. Rate is equal to 0.25 copies per second. Time is equal to 4 seconds. Work equals rate times time, which equals 0.25 times 4, or 1 copy. If a pipe fills 2/15 of the tank per minute, then in 4 minutes the tank can fill 8/15 of the tank. Rate is equal to 2/15 of the tank per minute. Time is equal to 4 minutes. Work equals rate times time, or 2/15 of tank per minute times 4 minutes. Simplify. 8/15 of the tank. In 4 minutes, the pipe fills 8/15 of the tank. Important. Once we know the working time alone, we can find the rate. Example. A printer works X plus 3 hours alone to print 1 book. The printer's rate is 1/x plus 3 of the book per hour. Important. Once you know the rate and time, we can find the work. Example. Rate is equal to 1 over the quantity X minus 2 liters per hour. T is equal to X hours. Work equals rate times time. Work is then equal to X over the quantity X minus 2 liters. Working together, Jennifer and Lori can plant a vegetable garden in 3 hours. If Lori works alone, it takes her 8 hours longer than it takes Jennifer to plant the garden. How long does it take Lori to plant the vegetable garden by herself? Construct the work rate timetables for Jennifer, Lori, and their work together. Working together, they plant it in 3 hours. 1 garden is the work. The time is 3 hours. If Lori works alone, it takes her 8 hours longer than it takes Jennifer to plant the garden. Let X equals the number of hours Jennifer needs to plant the garden alone, X greater than 0. X plus 8 is equal to the number of hours Lori needs to plant the garden alone. Remember, once we know the working time alone, we can find the rate. So Jennifer's rate is 1/x plus 8 of the garden per hour, and Lori's rate is 1/x of the garden per hour. Once we know the rate and the time, we can find the work. Work equals rate times time. Jennifer's work is equal to 3 over the quantity X plus 8 of the garden, while Lori's work is equal to 3/x of the garden. The fraction of the garden worked by Jennifer plus the fraction of the garden worked by Lori equals the entire garden. This fact leads to the rational equation 3 over the quantity x plus 8 plus 3 over x equals 1 on the domain open interval 0 infinity. Find the LCMD. The LCMD is x times the quantity x plus 8. Bring to the same denominator, amplify. We obtain on the left-hand side of the equation at the numerator 3x plus 24, and on the right-hand numerator x squared plus 8x. Multiply both sides of the equation by the LCMD, which does not equal 0. Add like terms. Equivalent to 6x plus 24 equals x squared plus 8x. This is a quadratic equation. Add negative 6x and negative 24 on both sides of the equation. Apply the reflexive property of an equation. Equivalent to x squared plus 2x minus 24 equals 0. This is a quadratic equation with a leading coefficient of 1. We can use the guess and check technique to solve the equation. The sum is positive 2. The product is negative 24. The two numbers that add up to positive 2 and multiply to negative 24 are positive 6 and negative 4. Thus, this is equivalent to the quantity x plus 6 times the quantity x minus 4 equals 0. Utilizing the zero product property, x1 is equal to negative 6 and x2 is equal to 4. Negative 6 does not belong to the domain, so that doesn't work. But x2 equals to 4 belongs to our domain. How long does it take Lori to plant the vegetable garden by herself? So since x is equal to 4, x plus 8 is equal to 12. Thus the answer is it takes Lori 12 hours to plant the vegetable garden by herself. Two painters working together can paint a house in 10 hours. Working alone, the first painter can paint the house in 15 hours. How long would it take for the second painter to paint the house working alone? Construct work rate timetables for the first worker, second worker, and their work together. Two painters working together can do it in 10 hours. So we fill in time 10 and work one house for the together section. Working alone, the first painter can paint the house in 15 hours. Remember, once we know the time working alone, we can find the rate. The first worker does 1/15 of the job per hour. Once we know the time and the rate, we can find the work. Work equals rate times time. The first worker then does 10/15 of the job in the set time of 10 hours, or 2/3 of the job when simplifying. Let x equal the number of hours the second painter needs to paint the house working alone. Thus the rate is 1 over x of the job per hour. Work equals rate times time, thus that the work is 10 over x of the job. The fraction of the job done by the first painter plus the fraction of the job done by the second painter equals the entire job. This fact leads to the rational equation 2 over 3 plus 10 over x equals 1 on the domain open interval 0 infinity. Separate the variable, add negative 2/3 on both sides of the equation. 10 over x equals 1 over 3. Two equal fractions make a proportion, cross multiply to find x. X equals 30. How long would it take for the second painter to paint the house working alone? X equals the number of hours the second painter took to paint the house alone. X equals 30. Thus, it would take the second painter 30 hours to paint the house alone. When she works alone, Jennifer can feed all of the animals in the pet store 2 hours faster than James can. After working for 4 hours, James has to quit to help customers. At this point, Jennifer takes over feeding the animals. It takes her 3 hours to finish feeding the animals. How long would it take each of them to feed the animals working alone? Construct work rate timetables for Jennifer and James. Let x equals the number of hours James can do the job alone. X minus 2 is then equal to the number of hours Jennifer can do the job alone, such that x is greater than 2. Remember, once we know the time working alone, we can find the rate. Jennifer's rate is 1 over x minus 2 of the job per hour, and James's rate is equal to 1 over x of the job per hour. After working for 4 hours, James has to quit to help customers, therefore his time is 4 hours. Remember, once we know the rate and the time, we can find the work. Thus, the work is 4 over x of the job. Jennifer worked for 3 hours to finish the feeding, thus their time is 3 hours. We know the rate and the time, we can find the work. 3 over x minus 2 of the job. The fraction of the job done by Jennifer plus the fraction of the job done by James is equal to the entire job. This fact leads to the rational equation, 3 over the quantity x minus 2 plus 4 over x equals 1 on the domain open interval to infinity. Find the LCMD. The LCMD being x times the quantity x minus 2. Bring to the same denominator by amplifying. The numerator of the left-hand side is then equal to 3x plus 4x minus 8. And the numerator of the right-hand side is x squared minus 2x. Eliminating denominators, multiplying both sides of the equation by the LCMD, which is not equal to 0, and grouping like terms. Equivalent to 7x minus 8 equals x squared minus 2x. This is a quadratic equation. Bring all terms on one side of the equation. Add negative 7x and positive 8 on both sides of the equation. Apply the reflexive property of equations. X squared minus 9x plus 8 equals 0. This is a quadratic equation with a leading coefficient 1. We can use the guess and check technique to factor the trinomial. The sum is equal to negative 9, and the product is equal to positive 8. The two numbers that add up to negative 9 and multiply to positive 8 are negative 1 and negative 8. Thus, the equation is equivalent to the quantity x minus 1 times the quantity x minus 8 equals 0. Zero product property results in x1 equals to 1 and x2 equals 8. However, x1 does not belong to a domain open interval to infinity, but x2 does. How long would it take each of them to feed the animals working alone? X was equal to 8, so x minus 2 is equal to 6. Thus, the answer of this question is, it would take Jennifer and James 6 hours and 8 hours respectively to feed the animals at the store working alone. When she works alone, Truda takes 4 hours longer than it takes Ivo to clean the bathrooms in the gym. After working for 3 hours, Truda quits for the day. If it takes Ivo 6 hours to finish cleaning the bathrooms in the gym, how long would it have taken Truda to clean the bathroom by herself? Construct the work rate timetables for Truda and Ivo respectively. She works alone. It takes her 4 hours longer than it takes Ivo to clean the bathrooms. Let x be the number of hours it takes Ivo to do the job alone, such that x is greater than 0. The number of hours Truda takes to do the job is equal to x plus 4. Thus, Truda's and Ivo's rates are 1 over x plus 4 and 1 over x respectively. Truda works for 3 hours and then quits for the day, so her time is 3 hours. And Ivo takes 6. Work equals rate times time for Truda, so her work is 3 over x plus 4. Ivo's time is 6. His work is 6 over x of the job because work equals rate times time. The fraction of the job done by Truda plus the fraction of the job done by Ivo equals the entire job. This fact leads to the rational equation 3 over the quantity x plus 4 plus 6 over x equals 1 on the domain open interval 0 infinity. Find the LCMD, which is x times the quantity x plus 4. Bring to the same denominator by amplifying. The left-hand side of the equation's numerator is 3x plus 6x plus 24, and the right-hand side is x squared plus 4x. Eliminating denominators, multiplying both sides of the equation by the LCMD that does not equal 0, adding like terms, we obtain 9x plus 24 equals x squared plus 4x. This is a quadratic equation. Bring all terms to one side, adding negative 9x and negative 24 to both sides of the equation, using the reflexive property of equations. X squared minus 5x minus 24 equals 0. This is a quadratic equation with a leading coefficient of 1. We can use guess and check technique to factor the trinomial. The sum is equal to negative 5, and the product is equal to negative 24. The two numbers that add up to negative 5 and multiply to negative 24 are positive 3 and negative 8. Thus, we have the quantity x plus 3 times x minus 8 is equal to 0. Using this zero product property, x1 is equal to negative 3, x2 is equal to 8. x1 does not belong to the domain, but x2 does. Thus, let's find how long it would have taken Truda to clean the bathroom by herself. If x is 8, x plus 4 is equal to 12. Thus, it would have taken Truda 12 hours to clean the bathroom by herself. Two identical printers are printing the payroll for College of the Sequoias. After they work together for 4 hours, one of the printers breaks down. The second printer takes 3 more hours to finish the job. How long would it take for one printer working alone to print all of the payroll? Let x equal to the number of hours one printer would take to print all of the payroll working alone. The printers are identical, thus each of them has a rate equal to 1 over x of the job per hour. Constructing the work rate timetables for the first and second printer. After they work together for 4 hours, one of the printers breaks down. Thus, one printer works 4 hours. Work is equal to rate times time, or 4 over x of the job. The second printer takes 3 more hours to finish the job. Thus, the second printer works 4 plus 3, which equals 7 hours. The work done by the first printer plus the work done by the second printer equals the entire work. This fact leads to the rational equation 4 over x plus 7 over x equals 1 on the domain open interval 0 infinity. Performing calculations, 11 over x equals 1, x equals 11, which belongs to our domain. How long would it take for one printer working alone to print all of the payroll? X equals 11, thus it would take one printer 11 hours to print all of the payroll. Two pipes are filling a pool with water. Working alone, the smaller pipe would take 3 hours longer to fill the pool than the larger pipe. After working for 2 hours alone, the small pipe breaks. It takes the larger pipe 2 hours to finish filling the pool. How long would it take the large pipe alone to fill the pool? Since it takes 3 hours longer for the smaller pipe to fill the pool than the larger pipe, let's let x equal the number of hours the larger pipe would take to fill the pool alone. And x plus 3 is thus the number of hours the smaller pipe would take to fill the pool alone. The rate of the larger pipe is 1 over x of the job per hour, and the rate of the smaller pipe is 1 over x plus 3 of the job per hour. Constructing the work rate timetables for the smaller and larger pipe respectively. After working for 2 hours alone, the small pipe breaks. Time is 2 hours for the smaller pipe, and work is equal to rate times time. Thus, the smaller pipe's work is 2 over x plus 3 of the job. After working for 2 hours alone, the small pipe breaks. It takes the larger pipe 2 hours to finish filling the pool. Thus, the larger pipe works for 2 hours too. Thus, we can find the work of the larger pipe to be 1 over x times 2, or 2 over x of the job. The fraction of the job done by the smaller pipe and the fraction of the job done by the larger pipe equals the entire job. This fact leads to the rational equation 2 over x plus 3 plus 2 over x equals 1 on the domain, open interval 0 infinity, finding LCMD of x times the quantity x plus 3, bringing to the same denominator, amplify. The left-hand numerator is 2x plus 2x plus 6, and the right-hand numerator is x squared plus 3x. Eliminating denominators, multiply both sides of the equation by the LCMD, which does not equal 0, and grouping like terms. We obtain 4x plus 6 equals x squared plus 3x. This is a quadratic equation. Bring all terms of the equation on one side. Add negative 4x and negative 6 on both sides of the equation. Apply the reflexive property of equations. This results in x squared minus x minus 6 equals 0. This is a quadratic equation with a leading coefficient of 1. We can use the guess and check technique to factor the trinomial. The sum is equal to negative 1. The product is equal to negative 6. The two numbers that add up to negative 1 and multiply to negative 6 are negative 3 and positive 2. This is equivalent to the quantity x minus 3 times the quantity x plus 2 equals 0. Utilizing the zero product property, we obtain x1 is equal to 3 and x2 is equal to negative 2. x1 equals to 3 belongs to the domain open interval 0 infinity, while x2 equals negative 2 does not. How long would it take the larger pipe alone to fill the pool? Since we know x is the number of hours the larger pipe would take to fill the pool alone and x is equal to 3, the answer is the large pipe would take 3 hours to fill the pool alone. Huck Finn can paint a fence in 5 hours. After some practice, Tom Sawyer can now paint the fence in 6 hours. Part A. How long would it take Huck and Tom to paint the fence together? Number of hours Huck needs to paint the fence alone is equal to 5 hours. Thus, Huck's rate is 1/5 of the fence per hour. Number of hours Tom needs to paint the fence alone is equal to 6 hours. Thus, Tom's rate is 1/6 of the fence per hour. Constructing the work rate timetables for Huck, Tom, and their work respectively. How long would it take them to paint it together? Let x equals the number of hours Huck and Tom need to paint the fence together, such that x is greater than 0. Work is equal to rate times time. Thus, Huck's work is x over 5, Tom's work is x over 6, and the total work is 1 fence. The fraction of the fence done by Huck plus the fraction of the fence done by Tom equals the entire fence. This fact leads to the linear equation x over 5 plus x over 6 equals 1 on the domain open interval 0 infinity. This is a linear equation in variable x. Multiply both sides of the equation by the LCMD, which is 30. Equivalent to 6x plus 5x equals 30. 11x equals 30. Divide both sides of the equation by 11. X equals 30 over 11, which belongs to our domain. Since x is equal to 30 over 11 hours, that's equal to 2 8/11 hours, or approximately 2 hours, 43 minutes, and 38 seconds. Thus, the answer is it would take Huck and Tom 30 over 11 hours to paint the fence together. Part B. Tom demands a half-hour break while Huck continues to paint, and they finish the job together. How long does it take them to paint the fence? We reconstruct our work rate timetables for Huck, Tom, and their work together. Let X be the number of hours Huck takes to paint the fence working together with Tom. Work equals rate times time, so Huck's work is X over 5 of the fence. X minus 1/2 is the number of hours Tom takes to paint the fence working together with Huck. Work equals rate times time. So Tom's work is X minus 1/2 divided by 6. Amplifying this by 2 to simplify, we get 2x minus 1 over 12 of the fence. The fraction of the fence painted by Huck plus the fraction of the fence painted by Tom equals the entire fence. This fact leads to the linear equation x over 5 plus 2x minus 1 over 12 equals 1 on the domain open interval 0 infinity. This is a linear equation. Eliminate denominators. Multiply both sides of the equation by the LCM d equal to 60. 12x plus 5 times the quantity 2x minus 1 equals 60. Eliminating parentheses, applying the distributive property of multiplication over addition. Equivalent to 12x plus 10x minus 5 equals 60. Group-like terms, add 5 on both sides of the equation. 22x is equal to 65. Dividing both sides of the equation by 22, x is equal to 65 over 22, which belongs to our domain. So x equals 65 over 22 hours, which is equal to 2 and 21 22nd hours, which is approximately 2 hours, 57 minutes, and 16 seconds. Thus, the answer is it takes them 65 over 22 hours to paint the fence, with Tom taking a half-hour break. Suppose that they have to finish the fence in 3.5 hours. What's the longest break that Tom can take? We construct our work rate timetables again. Huck's time, Tom's time, and the together time is 3.5 hours. Huck does 3.5 over 5 of the fence, which we amplify to simplify, or 7/10 of the fence. Let x equals the number of hours that Tom painted the fence, such that x is greater than 0. Tom's work on the fence is x over 6 of the fence. The fraction of the fence painted by Huck plus the fraction of the fence painted by Tom equals the entire fence. This fact leads to the linear equation 7 over 10 plus x over 6 equals 1 on the domain open interval 0 infinity. Eliminating the denominators, multiplying both sides of the equation by the LCM d equal to 30. We obtain 7 over 10 times 30, which equals 21. X over 6 times 30, which equals 5x. Thus, this equation is equivalent to 21 plus 5x equals 30. This is a linear equation. Separate the variable. Add negative 21 on both sides of the equation. 5x is equal to 9. Dividing both sides of the equation by 5. X equals 9 over 5, which belongs to our domain. X is equal to the number of hours Tom's painted. X is equal to 9 over 5 hours, which is 1.8 hours. The total time to finish the fence was 3.5 hours. Thus, the number of hours that Tom could take a break would be 3.5 minus 1.8, which is equal to 1.7 hours. 0.7 hours is equal to 7 over 10 times 60 minutes, which is 42 minutes. So 1.7 hours is equal to 1 hour and 42 minutes. Thus the answer is, the longest break Tom could take is 1 hour and 42 minutes.